Let's go. Let's start with functional programming. Thank you everyone for coming. Before we start, I just want to know the audience. Who here considers themselves as a Kotlin developer? There are some folks. That's great because I will cover that as well. Kotlin is great for functional programming. Dart, not so much, but we will come to that. Okay, before we start, I will not bluntly show you some advertisement about a project I'm working on, but if you're interested in user feedback, you might want to integrate Wiredash in your Flutter application and get quality user feedback. But now let's talk about functional programming. I'm Pascal. I'm a Google developer expert for Flutter and Dart, and I am working at an agency. We are 15 people, and my work is basically to make sure that the teams work. I'm the technical lead there. And if there is any problem, they come to me. And it's my own responsibility for myself that I try to achieve a code quality, a code standard, so that people are not coming to me because they have a problem, but instead they can solve it themselves. Functional programming is a big part of that because functions are very easy. And if you use pure functions, it's very unlikely that you do any mistakes. So I teach my developers functional programming to make sure that I have less work to do. What you will not learn today is either task, monads, functors, things like that. These are like really hard functional programming stuff. I will not go into that. We stay at the high level. Instead, we will talk about pure functions, and we will talk about immutable data structures. Then we go a bit deeper, and I will tell you about first-class functions and high-order functions. This is where the fun really begins. Afterwards, I will give you a brief outlook what the Dart and Flutter team is working on, especially the Dart team, for the future to make functional programming much better in Dart. So let's first of all talk about the elephant in the room. The problem is that Dart, by design, is a pure object-oriented programming language. And this is a big difference compared to Kotlin and Swift. Those are hybrid languages. They have functional parts, they have object-oriented parts. So Dart is not very functional, to be honest. But this doesn't mean that we can't use functional programming. Actually, every programming language that supports functions, we can use functional programming there. So let's see how it works with Dart. This is an example I want to use today. It is some shop, some inventory system. We see a list of products, and we can sort them by price. We can sort them by rating. Easy, right? Think about how would you implement this? Let's start simple. How would you actually, what information do you actually need to draw that screen? When I thought about this, of course, we need a list of products. Cool, easy. Also, we need some fields that we sort by, and we need the sort order. So with these three information, we can basically represent the whole screen. This is the product, just for completeness. I think this is not very important. And also the enums I created for this. With that, we can think about, okay, what should actually happen if you tap one of those labels at the top? If we tap something, we probably get an on-tap listener somewhere, and we implement that function. It's quite easy. If we tap the same field, we toggle the sort order. And if we tap on a different field, we reset the sort order, and we switch the sort field that the product list should be sorted by. Next, we need to update our product list. And this is where the fun part begins. This is based on the sort order. This is based on the sort field. There's the naive approach, and this is by using the sort function, which is built into the Dart SDK. We pass in a compare function and then sort the elements in that list. Quite easy to implement. It looks something like this. So this is just one part of this. So if we sort by the discount, we call the sort function, and depending on the sort order, we either compare A to B or B to A. Easy, right? This is the full, complete code. And actually, this code is working. So I ripped this out of this app, and this is the full source code there. The app is working, everything is fine. But today's task is to make this a bit more functional, and I will later tell you why this is not very functional, to be honest. Let's start with functional programming. And with functions, which is the basic of functional programming. Functions, I will use different terms today. Sometimes I call them lambdas, closures, methods, callbacks, things like that. In essence, they are all just functions. You know functions, you know functions. It's every time the same thing. Sometimes they are called top-level functions or anonymous functions, predicates. In the end, it's still a function. Everyone here knows functions. So we are on the same page. Let's look at this function here. It's the format price function. It takes in an integer and returns a string. We can assume what it does. So here are some examples. If we put in 12, we probably get something like 12 cents. Maybe you expected like 12 cents in dollars, but it doesn't really matter. The same input usually produces the same output. It changes if we introduce a global variable. The whole system now has changed because this function now suddenly has multiple input variables. We could use this global function inside of that body. Again, we don't see the body, we just have to make assumptions about this function. And suddenly the input is 12 and this global variable, and the output might be completely different depending on the state of that global variable. Even worse, it could also change the global variable. We don't know that. And this is a big problem because this makes it much more complex, and you can argue the more global variables there are, the more complex the whole function might be. It could be quite simple, but theoretically, it could use as many shared mutable global objects as it wants. And this is problematic because then the function is not pure. Why do we care about pure functions? A pure function is a function that has no side effects. This means it only cares about the input parameters and returns an output parameter. It does not mutate the input parameters, and it therefore always returns the same result. It doesn't care about the global state. It doesn't use it. If you provide something, you should provide it as a parameter. You also have to make sure that you are not using impure function inside of your body. There's no static analysis check that can help you with that. That's something we have to make sure that it doesn't happen. And once you have this pure function, you can even replace it with a lookup table. And this is always a check you can do in your mind. Could this function be replaced with a lookup table, even if the lookup table is gigantic? But could it be replaced? Yes, then it's a pure function. But why is that so important? It gives us a few advantages. First of all, the functions could be executed in any order. And not here in Dart, but there are functional programming languages out there where the compiler reorders the function during compilation because it's possible and it might be more efficient at some point. We can also execute these functions in parallel, so you don't have to think about, can I move this function to another isolate? Yes, you can. It's just a function. There's no shared state. The results can be cached. If it's a super expensive function, you can cache it, which is very helpful. And you will have to trust me on that. Pure functions are much easier to test than non-pure functions. And because pure functions are, the scope is quite limited. You have this one function, it might be longer or shorter, but there is no global state. You don't have to look into other files. There are no surprises, and it's very easy to focus on that little function. So where do we go with that? First of all, to have pure functions, we have to use immutable data structures. Lists by default in Flutter are mutable. This is a problem, but we can work around this. So when you're writing your Dart code in a functional way, try not to use mutable data structures in the way that you normally would. Do not call the add or remove function on a list. Instead, always create a copy. This makes debugging especially easy because you can always see, oh, this was the list before, this was the list after that change, and you compare each other. If you're using with mutable data structures, it's the same reference, it's the same list. You cannot compare what was before, what was after. Same with normal data classes, for example. Do not create mutable fields. Instead, use a copy with method and create a copy of that user when you want to mutate a field. Again, easier to debug. You can see what was the field before, what is it in a new object. A few libraries help you with that. First of all, Freest, which is very helpful for data classes. KT-Dart, where I'm the author from, which is very good for the Kotlin people because I ported the Kotlin standard SDK over to Dart. So all the functions you are used in Kotlin are now also available in Dart, including the immutable data structures. So we now have a KT list and a KT map, which are immutable by default. And these are much better than the Dart list, in my opinion. If you really want to go deep into immutable data structures, you should check out the fast immutable collection library. It is very cool what they achieved because they are very, they are not that memory consuming. They actually do not create a copy, but instead have other mechanisms to be very efficient when you mutate some things. Or not mutate something, but when you create copies. If you want to learn more about immutability, please check out the YouTube channel Flutter School. There's a video of me talking deeply about immutable objects. Okay, let's go back to functional programming now that we have finished the immutable stuff. We, first of all, want to avoid mutations and we want to avoid side effects. Let's go back to our method and apply those rules. So first of all, what are the mistakes here? We mutate products. We call the sort function on products. Products is a mutable list. That's a problem. The second thing, we are accessing the sort order property, which is somewhere within our class. We shouldn't do that. So first of all, we extract a method. That's always something we can do. Extract a method, and this method becomes pure. It becomes pure because all the input variables are what's happening within that function. It doesn't access anything globally. Everything is provided as an input parameter. We have all our three parameters, and we return a new list because we, first of all, create a copy. And once we created that copy, we returned it. Next, we can basically reuse the code we wrote before and use the sort function, but only on the copy we did. So we are not changing the input products list, but we only change the copy and return a new list at the end, so nobody else can manipulate it. This is a nice pure function. We did it. We introduced a pure function to a Flutter application. Where can we go now? First of all, we can check, is it really beneficial for us? Yes, we could theoretically execute it in any order. It could be executed on another isolate, which for a big product list would be helpful. It can be cached. Again, big list. If you toggle a button, it is very likely that you have the same inputs again. And we could finally test it. Otherwise, before you could only write a widget test for it. Now you can just call this function. It could be a top-level function, and you can just call it in your test and test that. It's also quite easy to focus. I mean, it fitted on a slide, so there are no big questions. So level 1 completed. We learned about pure functions. Let's go deep into functional programming, and I present you fun with functions. Now it gets a lot of fun. So first of all, let's talk about high-order functions. It sounds scarier than it actually is. Higher-order functions are functions that either receive or return a function. It looks like this. You have some function, you get an input parameter, which is also a function, or you might return a function. Both is possible as well. So you might get an input parameter and a return value, and both are functions. This is called a high-order function. And how can we use this? Here's another example. So assume we want to get only the products with more than 4-star rating. We loop over that list and check for the rating, and if it's greater than 4 stars, we add it to the list on top and return the result at the end. Nothing is wrong with that function, but imagine what happens if you want to write a function that returns you more than 3 stars. We have to change something. What we actually have to change is this part here. Product.rating is greater than 4, and traditionally you would change this by creating a new parameter. Now we don't want to change product rating greater than 4, but we inject this variable. But we could be a bit better, or we could make it a bit more general by introducing a function called a predicate, which allows us to choose if we use that item or not, and instead we put a lambda inside. So not only a value, 3 or 4, but instead a lambda which executes on every item. Suddenly, this function, which was previously called get products with 4 stars plus rating, is now only called get products, and it can be used with multiple filters, basically. That's very helpful, and that's why things like that are already in the standard SDK. It's called the where function. In other languages, it's called the filter function. If the Kotlin people here are not happy with the where name, in KTJOut there is a filter function, so you can use that, and it makes more sense if you work with multiple languages. So we can throw away the top part here because the where functions is all we need, and it's now quite flexible. And if you compare this to a traditional way, I think this solution is a bit better. So how do we, or let's first ask this question, isn't it expensive that we create now lambdas all the time? It's a valid question. The answer is no, it doesn't really matter. Garbage collection is good enough, but we could do something about it. Instead of providing a lambda, we can just define a function and use a function reference. So at the bottom here, I put in the name of the function. It references the function which was defined before, and it is not recreated every time that code is executed. Whereas on the top, it always recreates the lambda when this line is executed. So problem solved, and function references are a big part of functional programming because we now talk about the coolest feature, which is that functions can be used as first-class citizens, which means we can use functions the same way that we are using objects. And let this sink in. So we take any function, and we can save this function or this function reference as a variable. Like an object, you can create a variable and point it to a function. Easy, right? We can go one step further. We can even create a list of functions or a map of functions. And you can add additional functions. It could be a function reference. It could be a lambda. They are all the same thing, functions. Now, let's apply this to the code before. So this was our sort products function. Cool. But let's apply the high order function, first level function things. First of all, this is a big change. I replaced the switch case with a long nested if else. Same thing, but long and nested. It will become better. What I want you to focus on here is that we now have multiple lambdas here in each switch case. Actually, not switch case, in each branch of the if else. And they look quite similar, don't they? First of all, they look similar because they have the same shape. They are the same kind of function. So by that, we can extract it into a variable and save it on top, and only call the sort function, the copy.sort function at the very bottom, using that variable. Okay? Next, because the functions are all quite similar, we can save them in a list or a map here. So for each sort field, I define a sort function. And I save them in a list, and they are there saved, and they won't get recreated every time. So they're just there sitting there to be collected. Next, because they look identical, or they are identical, the blue one at the top and the blue one at the bottom, they are identical, we can replace them. This means we can rip away the whole part at the top and just do a lookup on that table. For every sort field, we get a new lambda, which is the compare lambda, and we sort by that. It's suddenly a lot less code, so we can reduce it. What I haven't told you, we totally forgot about reversing the sort order, and that's where a high order function comes in. The reverse function, that's a bit complex. The reverse function is an extension function, first of all, and it reverses the function with 2 parameters by swapping the parameters. So this is meant by high order function, a function that takes in a function and returns another function and does something with it. By introducing that, we solve that problem too, and simply can keep our list, which just compares or gives us a lambda for each sort field, and we can swap the sort order depending on the sort order we get in the input parameter. Lastly, we can shrink the code a bit more by introducing or by collapsing the lines here into a single line. And this is our final solution. And I call this the vanilla Dart solution for that thing, which is a bit more functional and, in my opinion, a bit better maintainable. But we can go further. So you might ask yourself, aren't there packages out there for Flutter or for Dart that help us with functional programming? Yes, there are. There are some very dedicated functional programming packages. I don't want to get into those as much. Let's stay with some basic concepts. So for example, the reverse functions, the reverse function here. That's something which is quite common, and this is already part of the ktdart library. Kotlin developers here will know there is a reverse function on a comparable, and you can reverse it automatically. Cool, let's use the compare function, and we can remove our code at the bottom. And the next thing is, this line is quite long and ugly. We can replace this with dartx, which is another library, which gives us the sorted with function. The cool thing about these sorted with functions, and in general the functions of the dartx library, it is very much inspired by Kotlin, and it always returns a copy of that list. So we do an operation on a list, it always returns us a copy. So does the sorted with function, it returns a copy, and yeah, we can save a lot of code there. The last thing we can improve, it's just a little thing, but you can see here for the lambdas, basically call twice a.rating, compare by b.rating. So a.rating and b.rating are quite similar, so we can replace that by just use a lambda which gives us a.rating or it.rating, and use the compare by function also from the ktdart package to give us a comparable, to create a comparable by comparing the same field of all objects. This, my friends, is the final solution I want to present you today, and I call it functional Darty solution because it's a bit more Dart. And we can compare it to the other solution we had before. I claim that my solution is now a bit better and a bit cleaner, and we can compare it by different aspects. So for example, what about if we want to extend it? What happens if we add new sort fields? In this solution, we add a single line at the bottom into the map. In the old solution, the naive solution, we would have to add a lot of code. Every time there's a new field, there has to be a new field added. Also, the sort products function here is testable. The naive solution, not so much, to be honest. So, are you convinced that functional programming is better? Raise your hands. Some are convinced. Okay, let's continue. If you're not convinced yet, here are some other aspects you might want to think about. Do you ever had flaky tests? You can't have flaky tests with functional programming because all the input parameters are there. They cannot change. You don't have global state, which might introduce flakiness. So with with functional code, you don't have flaky tests. That's cool. Easier to debug. I talked about this before, and usually easier to refactor because for functional code you have tests. Once you have tests, it's usually easier to refactor. Threads safe by design, which is not a big problem in Dart because everything is single-threaded and we don't have shared memories between threads. But in general, functional programming is thread safe. So if you're using Kotlin and Java, it might help you on those platforms. Please take functional programming as a new tool in your toolbox. You can use it, but you should not overuse it. Use it where it makes sense. And let's go back to the elephant in the room. Dart is still an object-oriented programming language. The thing is, this might change. The Dart team is actually actively working on patterns and related features, which is like if you know programming languages like Haskell, pattern matching is something which is used all the time in functional programming. And the Dart team is actively working on that. And I want to show you some of the ideas which they are actually implementing. So this is completely specified. That's why I can show you some code examples, but it's not fully implemented. The issue contains multiple return values, algebraic data types, patterns, destruction, and so on and so forth. I show you the code. First of all, we will get records. This will be something we will get probably in Dart 3. And Tuples are basically a set of variables. You can think about this as a data class in Kotlin, but without a name. So multiple libraries can create records of the same shape, and they can exchange them with another without actually depending on each other, which is a really cool feature that Kotlin actually lacks. So we will get tuples, and this automatically allows us to return multiple values from a function, which could be very useful if you work on GIS applications, for example. You get a lot of lat-longs. You can now return that from a function and also use destruction, meaning that a function can assign the value to multiple values automatically. That's a feature that was already built into Kotlin, and I'm very happy to see this finally coming to Dart. Pattern matching, which is, I think, the biggest part of that thing they are working on, is quite cool. It's basically like an advanced switch case, which we will have in the future. First of all, no break anymore. That's really cool. The next thing is that you can match by identity, by equals, and also by type. If you check the example at the bottom, it's just a function which accepts an object. You could put in any object, but if you put in a rect, the switch case will, actually it's just, yeah, it's a switch case, will detect that it's a type of rect, and you can work with that rect from there on. There's a slight problem when I personally read the specification. They explicitly exclude immutable data structures. They plan to implement everything by supporting the existing mutable data structures, list and maps. This has some drawbacks. The implementation gets much more complex, and I'm actually not sure how it turns out. But I mean, we can help ourselves. There are packages out there that support immutable data structures. So we can use that, and eventually, once the Dart team goes more into functional programming, they will decide for themselves, oh, it's finally time that we introduce immutable data structures. I personally hope so. Let's do a quick recap. What you learned today, first of all, pure functions are cool. They are testable, they have no side effects, they are quite easy, and they have usually no bugs. Immutable data structures are required if you want to have functional programming. The best you can do is always create copies if you don't have immutable data structures. We learned about first-class functions so that we can use functions like objects, we can store them in variables, in lists, and so on and so forth. And we learned about high-order functions, functions that take a function and return a function eventually, like the reverse function we did. Thank you very much, and do yourself a favor and write more functional code. You will thank me later. Thank you. I think we have a bit time for questions. Don't do it with a microphone. Come over to me and we can talk this in person. Thank you very much.